session we are going to see about the exploratory of data analysis part, where we are going to handle a huge data and explore in various aspects. So the data analysis has been carried out in various exploratory ways. So we are going to see about the dataset we used is the World Happiness Report, and the features that are adapted to this dataset are GDP per capita, family, life expectancy, freedom, generosity, trust, government, corporation. So as a first step to have the exploratory data analysis to import the header files. So before going on to the practice session, we can able to have a general intro on exploratory data analysis, where we are going to have the data distribution examine part, and the second one we are going to handle the missing information. The third part is going to be handling the outliers, and then we can able to have the removal of the duplicate values. Further, we can able to encode the categorical value to numerical value, so that the model which you are going to adopt it can able to suit for the numerical values. Then as a final part, we are going for the normalization and scaling, so which is going to be a mandate in data analysis. So feature scaling is a mandate procedure for each and every data analysis part. So to begin with, we are importing the libraries. So NumPy for having the mathematical calculations, pandas to handle the data, matplotlib for having the visualization part, and seaborn also for visualization part. I have been declared as variables for those libraries. So we are going to import the data set using the read CSV method, importing this particular data set. As we have been described, the data set is going to be from World Happiness Report. We are handling it as a data frame. So here the data frame is going to be the happiness data. So we are going to visualize few information related to the data set. So having the head method of it. So head method which returns only 5 rows of the typical data set. And we are going to have the information. Before going to print the information, we are having the shape of the data in such a way that what is the dimension of the data, how many rows and how many columns are there in the particular data set. We are exploring it, and after that we are having the information related to the particular data set. So information can be able to be related to their column name, how many null values are there, what is the data type that relates to, what is the memory space allocated to that particular data set. So as of running to this, we have, this is the particular data set having the overall rank, country range, score, GDP per capita, social support, health, life expectancy, freedom to make life choices, generosity, perspectives of corruption. The shape of the data is going to be the number of rows and the number of features added to it, and the info is going to be non-null. So all are having the values except the perspectives of corruption. Going to be one missing value is there, and data type is going to be integer, and country or region is going to be the character, so it is represented as object. The others are integer value, floating values. Next we are describing about the data similar to the info. Here we are describing in terms of mathematical aspect. So what is the count of each column and what is their mean. So we are having the mathematical computations in terms of each column. So mean, standard, minimum value, what is the minimum value and what is the maximum value, what is the 25% of the data set of the data and 50% of the data, 75% of the data, what is the point that covers with 25%, what is the point that covers for 50%. What is the point that covers for 75%? And what is the maximum value? So these are the values, information that can able to be grasped from the described info. Next, we are going to see whether it has null values or not. So this is going to be the mandate procedure, since if a data set having missing values, the model cannot able to produce the accuracy cannot able to generate an accuracy model. So for that, as a prior process, we are going to check whether the features holds null values or not. So all are determining as 0 except the perceptions of corruption is going to be 1. So we need to have elimination over to this null values. So eliminating these null values can be able to handle up in different perspectives. One is removing of data. So removing of data can lead to loss of information. So we won't follow this strategy. And the second way is having median, mode, or standard deviation, or you can able to have the regression technique also. It can able to predict what type of value that this particular row holds. So in this, we are adopting median method, median strategy to replace the null value. So for replacing the null value, we have been calculated the median method for MP, and this MP can able to be replaced for the array which has NaN and in place is equal to true. The in place is equal to true, which means that we are not going to have a copy of that particular data frame. We are just going to just replace it on the same data frame. I am checking whether null exists or not. Checking once again with the same set of command is null.sum. So it generates not null. So all have unique values, and we can able to find whether it has the duplicate values or not. If we find the duplicate values, it have to be removed from the data set. We are just going to run it. So this data set which you are handling it doesn't have any duplicate values. So if there is any duplicate values, you are supposed to remove the duplicate values using the drop duplicates and pass the in place is equal to true, so that we are not going to have the copy of the data frame. We are just going to make changes in the same data frame, and we are just going to have a box plot. So when you are having a box plot, we can able to identify the outliers. The outliers here present is the two values which are presented in the range of point less than 0.5. So we are supposed to remove these outliers. So outliers are those information which has been found outside the range of the values in the given data set. So those data which are those values which are found outside the range of the form have to be removed, so that the model can able to generate the accurate values. Accuracy of the model can be generated. So removal of outlier can able to be done with interquartile range method. This interquartile range method is used to find the difference between 25th and 75th percentile of the data. So this identify the outliers by identifying the limits on the sample values that are of a factor of k. So here the k value is going to be 1.5. We are just going to have the limits for the ranging sample of values with a factor of 1.5. So we are going to identify the minimum value and the maximum value. So minimum value going to have from the range of 0.25. So this is going to be leading with the higher score, higher edge, and this 75 is going to have with the lower value. So we are just going to have the lower range limit and the upper range limit using the quantile method which can able to produce two values. These two values will can able to identify what is my least score and what is my maximum score. And using this least score and the highest score, we can able to have the value which are outside the highest score, outside the range, can able to be assigned to the particular value which have been calculated. So we are going to just assign the maximum value to whatever the ranges which has been followed in the outside of the range, so that the data which has been found in the outside will be recalculated and will be fall under the particular box region. So this is going to be the range of data points which happens, and this is going to be the whisper where data points can able to be fall less than 0.25, and after this range of whisper there might be points that occurs. So this is going to be the outliers. These points have to be eliminated from the data set. So we have been removed the outliers from the given removal of outlier method. So we have been identifying what is my lower limit and what is my upper limit. With this lower limit and upper limit, we are just assigning those values to whatever the values which has been found in the outside the region. So once again we are going to plot this and check whether the outliers are exist. So here no outliers are exist, the outliers are removed. And the next one is the normalization part. So this is going to be this mandate procedure in a pre-processing stage as the value to the data can able to have a dominance over to the other factors. So we are going to follow this standard scalar method. Using fit and transform, we are going to have the standard scalar to be applied for that particular column of score. Converted into a standard scalar method. Able to have the visualization of all the variables, how they have been correlated with each other using map method. So we are having the correlation factor. This correlation factor is calculated by means of Pearson method, which has which allows the annotation to be true. That is the values which has been found for between the overall rank and the social support to be minus 0.75, and the C map, the color map is going to be red, yellow, green. Red is going to be highly extreme negative case, and yellow is going to be the mediate, and green is going to be the positive. So higher is going to be the green, and yellow is going to be the mediate, and extreme negative case is going to be the red. So here when you are identifying it, the score, the happiness score has 0.8 when you are compared with GDP per capita, and 0.75 when compared with social support, and 0.78 when compared with healthy life expectation. It produces the least score of 0.14 on generosity. So on seeing this, we can able to see that GDP per capita, social support, and health life expectancy is going to be more dependent on the particular outcome score. So this is going to be the significant features. Upon identifying the important features, we can able to eliminate the least significant variables, and once again we can test for the model. So this is going to be these three 3 is going to be the important independent variables. So this is one way of having the graphical representation. The other way of graphical representation is going to be the regression plot, where we are plotting with the x-axis to be GDP per capita and y-axis is going to be the score. As the GDP per capita increases, we found huge amount of data underlying this, which emphasizes that happiness is more on increasing the GDP per capita. And also in increasing the values of social support health, we find huge amount of data that could be able to be found over to the score. Happiness score has been increased as on moving on to the data. Similarly with health life expectancy and score, we found huge data on the data which found the for a good health person the happiness seems to be more. For freedom to make life choices and score, we found a scattered data where it seems that it is going to be less contributed. I think it is going to be 0.4. So freedom of data. So freedom of collecting data we have 0.54. So few of the data has been scattered. As on increases, we found more data accumulated to it. And finding the generosity versus score, as increasing the generosity, we found that the happiness has been reduced. So with this, you can able to have a summary of your exploratory data analysis part. So the steps we followed, we are examining the data distribution in terms of mathematical aspect, the statistical way, mean, and what is the 25% 75% to handle missing values. We can able to adopt strategies of mean, mode, or regression method. To handle outliers, we are implementing IQR, that is your inter-quartile range method. For removing the duplicate, we are identifying many duplicate values exist, just dropping the values of duplicate rows, and we are converting the category data to numerical values. And this final thing is we are making use of the normalization and scaling method for having the future scaling method. So finally we are analyzing with the graph that which variables will be highly correlated with each other. So using the correlation method of Pearson method, we are checking for the variables which are highly correlated from the heat map graph.